We introduced the idea of probability in Chapter 17 and some topics that were related to it, and now we're going to formalize our definition of probability and how to compute probabilities. A probability model describes all possible outcomes and says how to assign the probabilities to any collection of outcomes. A sample space is a collection of unique outcomes of a random circumstance. We usually denote this by a capital letter S. This is really a script S, and sometimes in other textbooks you'll see it denoted by omega. An event is a collection of outcomes. Suppose you are asked to toss a coin. What is the sample space? Well, S is going to equal all your possible outcomes in a list, and that's heads or tails. We usually put it in curly brackets. You toss the coin and it lands on tails. What is the outcome? It was a tails. If you toss the coin 3 times and it lands on tails, then heads, tails, heads, heads is called the event. This is your collection of outcomes. So we're going to learn some rules. Rules 1 and 2 are the only two that you kind of need to remember the numbers for. The other ones you just need to know how to use and what they mean. Rule 1 and 2 build the foundation for all the other probability rules. So Rule 1 says that a probability is a number between 0 and 1, and so if we observe an event, then we know that the probability is no less than 0 and no more than 1. Note that P of A, this notation here, this means probability of event A. So that's the way that we read that little notation. The capital P with something in parentheses is the probability of whatever's in the parentheses. Rule 2 says that all possible disjoint or non-overlapping outcomes together must have probability 1. An outcome must occur on every trial, and the sum of the probabilities for all possible outcomes must be exactly 1. That's the same notion as having all the parts of a whole makes just the whole. You can't make bigger than the whole or less than the whole. Consider the following assignment of probabilities about marital status. The marital status for women ages 25 to 29, we can assume never married, comes with probability 0.386, which is 38.6%. Married is 0.555, widowed is 0.004, and divorced is 0.055. Notice that each of these probabilities is a number between 0 and 1. The probabilities add up to be 1. If you check, you'll see that they add up to be 1. Any assignment of probabilities to all individual outcomes that satisfies Rule 1 and 2 is legitimate. A legitimate assignment of probabilities. This is a definition you need to know. It shows up in your homework. It usually shows up on exams. A legitimate assignment of probabilities is when it satisfies Rule 1 and Rule 2. That is, check to make sure that all the probabilities are between 0 and 1, none are negative and none are bigger than 1, and that they all add up to 1. Then you've got a legitimate assignment of probabilities. The third probability rule is the complement rule. And this is about the probability that an event does not occur. And to compute the probability that an event does not occur is 1 minus the probability that the event does occur. So suppose the probability of A is 0.7. So let's change that to something that we can envision. Let's say that A is rain. So the probability of it raining is 0.7, which means there's a 70% chance of rain. Well, you already know the complement rule. You can compute this in your head. If I asked you what's the chance that it's not going to rain, you would tell me 30%, or the probability of 0.3. So you can already do the complement rule. We're just putting it into formal language so that we can compute other probabilities that might not seem so clear. So, the probability of not A is the probability of something we call the complement. So not A, that is everything other than A, is known as the complement of A. And the notation for this is the event with a superscript of a C. It looks like an exponent. So A to the C means A complement. That is everything other than A. So we've already talked about this out loud, but we can compute the probability of not A. If the probability of A is 0.7, we just need to take 1 minus the probability of A, and that's 1 minus 0.7, which gives us 0.3. So if A has 70% chance, not A, everything other than A has 30% chance. Our fourth rule is the union rule. If two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. If this is true, the events are said to be disjoint. What do we mean when we say this? We're referring to the fact that they have no outcomes in common. Disjoint is two events have no outcomes in common. So if two events have no outcomes in common, if they can't happen at the same time, then we call them disjoint events. Suppose that A and B are disjoint, and you know that the probability of A is 0.4 and the probability of B is 0.35. What is the probability of A or B? Now, the word or goes along with a union. So when we see the word or, we're computing a union. So the probability of A or B, since they're disjoint, we have our rule that says if they're disjoint, we can just add the two probabilities. So that's going to be 0.4 plus 0.35, which is 0.75. A Venn diagram is going to help us picture events and sample spaces. When we draw a Venn diagram, we usually draw a box, and that denotes our whole sample space. And then we draw circles or other shapes to denote our events. So let's say that that's event A and B in there. Are those events disjoint? No. A and B in the picture here are not disjoint because they overlap. So a Venn diagram is a good way to picture events and probability spaces. So if they were disjoint, we would have had to have drawn the circles not overlapping with each other. Now the union rule that your textbook gives you is a really specific form of it, a very special case for when you have disjoint events. A lot of times we don't have disjoint events. So how can we generalize this union rule? Well, let's picture it using a Venn diagram with an example. Suppose the probability a student is in honors math is 0.25, and the probability a student is in honors science is 0.3. Now picture your high school. Honors math could have 25% of students enrolled in it, and we could assume that 30% are enrolled in honors science. Now, is everybody who's in honors math excluded from in honors science? No. There are people who are in both at the same time. Let's assume that the probability a student is in both is 0.2. We want to find the probability of the union. That is, probability a randomly selected student is in honors math or honors science or both. So we're going to picture this with a Venn diagram. Let's call this left circle HM for honors math and the right circle HS for honors science. So what is this right here? Those are the students that are in honors math and honors science, right? So we've got some students that are only in honors math. Those will be over here. The students who are only in honors science would be over here, and the students who are in both are in this intersection. So these events are not disjoint. They have an intersection. So how do we compute this union? We don't have that special case of being disjoint, but we can figure this out. So let's start with the way that we started before and add the probability of honors math to the probability of honors science. Now if we think of these circles taking up the amount of space proportional to their probability, we can kind of picture the honors math students here and the honors science students here. But if we just add the whole circle for honors math, which is what we're suggesting over here, and we add the whole circle for honors science, which is what we're suggesting here, what have we done wrong? We have double counted the students that are in both. They were already counted in the honors math circle, and then we also included them again in the honors science circle. So what can we do to correct for this? We can subtract out the probability of being in both honors math and honors science. So we know the probability of being in honors math is 0.25, and the probability of being in honors science is 0.3, and the probability of being in both is 0.2. We got that from the question. And that ends up being 0.35. So 35% of the student body is in at least one of honors math or honors science. Rule 5 is called the multiplication rule in your book. And it says if two events A and B are independent, then the probability of A and B equals the probability of A times the probability of B. Notice that we have a different criterion here than we did from that specific case of the union rule. This is actually a specific case of this multiplication rule where we have independence of events. If we want to get the intersection, that is the word and, in our probability, and we have independent events, then we can multiply the probabilities. What is independence? Independence means that the occurrence of event A does not affect the occurrence of event B. Coin flips and dice rolls are independent. If I asked you to estimate the probability that a randomly selected person is over 6 feet tall, you could have a number in your mind. If I gave you the additional information that they have a size 15 shoe, that would change your idea of the probability of them being over 6 feet tall, right? So in that case, your height and shoe size are not independent because knowing one affects the probability of the other one. Okay, so with this, let's do an example. What's the probability that the first roll of a die is even and the second roll is odd? So first, let's notice that we want to compute a probability, and let's notice the word and. That tells us that we're going to be in a multiplication rule setting. This is not the word or like the union rules. Now, we only have one rule for the multiplication rule, and that is if the events are independent. Are rolls of dice independent? Yes. So we're good to go. So the probability that the first roll is even and the second roll is odd is the probability the first roll is even times the probability of the second roll being odd. Since they're independent, we can multiply their probabilities. And what's the probability of rolling an even number on a 6-sided die? Half the sides are even. And what's the probability of rolling an odd? Half the sides are odd. So this probability ends up being a quarter. Let's make some important notes about these rules before we continue. The word or goes with the union, goes with the math symbol plus. And the word and goes with the word intersection and this goes with the math symbol multiplication. If you keep those together, it will help you compute these probabilities.